Okay, greetings everybody. Welcome to my new channel here, which is going to be dedicated to just repairing arcade monitors. And as you saw in the intro there, I'm not really a professional video maker. I don't have the tools and tricks and tips, so what you saw there is about the best that I'm able to do. So please forgive the amateurish style of filmmaking there. But this is just going to be a channel for repairing arcade monitor chassis, showing what to do, and fumbling my way through it, and hopefully it helps people out. So I just recently got, let me go back actually, all of my previous arcade monitor repair videos on my other channel, I'm going to end up at some point transferring over to this channel, so they'll all be congealed onto this one channel. But I just got a shipment of 6 chassis, 1, 2, 3, 4, 5, 6, from a friend, a fellow enthusiast who is kind of, he knows how to do cap kits and flybacks and basic troubleshooting, but anything past that, it's a bit out of his wheelhouse. So he asked me if he could ship me some stuff. I said, sure, I'll take a look. So I might as well make these videos here on the new channel, and hopefully it helps somebody out. So what we have here is a 25-inch K7000, and he sent a note along with all of these chassis. The first thing I notice here is that there's no remote board, but that's fine. I have a couple of remote boards that I can use, so that's not a big deal. Let's take a look at what he says here. He says, I tried to fix this, but I don't remember what it is. It goes, I don't know what that says. It goes something here in the garage, but I haven't made that much progress. Yeah, so I know nothing about this, unfortunately. So let's take this back out. So I don't know what's going on. There's not much information. Obviously, I got a remote board I'll have to plug in. But looking over it here, it appears to be in good, clean condition. It's not dusty or dirty. It looks like it's been through the cleaners, if you will. It obviously has a new cap kit installed. It's got a new fuse. It's got a new flyback. But since we don't know if it's working or not, I'm going to go through and do all of the testing on the power circuit and all that. I did notice previously that the filter cap, instead of being the small, it's been replaced, but they make a correct fat one as opposed to the tall skinny one. I don't like the tall skinny ones because of this particular reason right here. You can see that it's actually loose. I can move this around, and if you look at the pad moves up and down as well, that little guy right there. So the pad's loose, and it's not broken yet, but when you have the tall caps like this, that's the reason the factory puts glue on these. You'll notice some of these K7000s have the white or clear epoxy or glue around the cap. You can still see some of the remnants there of the white glue. They do that so the caps don't move back and forth and break off the solder pads. Case in point with this, you can see that's what happens when they do that. Plus it should be flat against the board and not sitting up like that. So we'll have to break out the fiberglass pen and scrape away some of that solder mask and fix that. But for the most part, that's the only real thing I see initially. These have a real bad tendency to get burned up in this area, so it's not too bad. It seems to be a very low-life K7000. There is one suspect pad right here which I'll reflow. But for the most part, yeah, it looks like it's in pretty good shape, but there are some mods here that I'm kind of not understanding. There's these 2 bodge wires here. I don't know what that's about. I don't know what this resistor's about. There's this white bodge wire. I don't know what that's for. The other side here has some components I'm not used to seeing. You can see here that there is a diode here, and there's a couple more resistors in series along with this white wire that goes through to the remote board harness. So none of this is going to keep it from powering up or give me any kind of power issues. So let's just go through and test all of our components, and we'll come back to this later if this proves to be some type of weird vertical or horizontal thing. It's most likely a vertical deal, vertical size deal, because it's how close it is to the vertical section here. But just so we can test to see if we have any power issues, let's go ahead and do all of our testing for our normal stuff that we do for the power circuit. Oh, here's another bodge wire. Not sure what this is. It's going from this jumper. There's a jumper here. It's going over here to this R26 leg, which looks like it follows across over to a vertical hold. Interesting. This wire here is going to this mess. Looks like it may have originated here on the vertical hold pot, because there's a wire missing, and if you follow this along the trace, it goes to that same location. So it appears to, anyway. It shares a trace with no, it goes to the vertical hold. So I'm not sure what's going on here, but like I said, that shouldn't keep it from powering up. So let's go through and do our testing. We'll start with R103, which should read about 2.7 ohms or 3 ohms, give or take. So we'll go to resistance, and we'll check R103. Again, R103 will blow your fuse and or keep it from powering up, because it's part of the power section for the rectifier circuit. So we'll check that, and we've got 3.2 ohms, so R103 is good. We'll check our diodes here in the power circuit, which is actually the bridge rectifier that converts the AC to DC, or vice versa there, yeah, AC to DC, or DC to AC, I forget, but that's why I say this is amateurs. So we've got the diodes in the power circuit. Now what'll happen here for the rectifier is if you hook this up to this chassis requires an isolation transformer, so if you hook this up to a machine that does not have a transformer, it will blow these diodes in the power circuit and cause other stuff to go crazy. Your fuse will go. It may even damage your HOT, your voltage regulator. So we always check that before we power it up. So we go to the diode tester, and like any diode, you put your there's a side with the stripe. Your negative always goes on the side with the stripe, and your positive goes on the side without the stripe. And you want to make sure you have a diode checker setting on your multimeter. So if we check these diodes here, we'll see that D23 is good, D24, and then we got D19, and D20, D21, and D22. So those are all good. All right. So again, yeah, when you read these diodes, they should read 0.5 XX, or because sometimes they can be 0.4 XX or 0.6 XX, but you want it to be around 0.5 XX. Anything other than that, it's going to be bad on you. So let's zoom back out actually a little bit. So now we can check our R104. Should be 15 ohms. Sorry. There we go. R101 is around 6.8K. Sometimes it can be around 4, depending on what other stuff's in the circuit, and whether it's 19 or 25. But 6.8 is the rating. And so yeah, as you can see there, it's only reading 4.2K, and that's in circuit. So, and there it's climbing. So you want to make sure that it's not actually open, or resistors don't short, they open. But if you're really worried about it, you can take one leg out of the circuit and check it. But that's a normal reading, even though it's stamped 6.8K. Like I mentioned before you even tested it, I mentioned it's like 4 something. So it's normally 4 point. Sometimes they read 6.8. Sometimes it's 4 point something. Like I say, it depends on the model and version of the K7000 you're working on. But that's a normal reading, so that's actually okay. Then we have R97. It should be 270 ohms, I think, give or take. Yeah, 271, so that's good. So that's all okay. Then we have, which one was this? R89. R89 is 3.7, 3.8 actually, I think. 3.7 is what's stamped on it. You can't see it, but 3.7 is what's stamped on it. So that's good. We can test our HOT, which again is this guy right here. For that, we'll go back to our diode checker, because the transistor is basically, there's a diode inside that acts as a switch. So again, you'll want to read, it's these 3 pads right here. It's a triangle basically, so you have 1, 2, 3. This triangle here by this hole. So your negative will go on the top of the triangle, and you should read 0.5 like a diode on each leg. In circuit, it'll read on each leg. Out of circuit, you'll only read it on one leg. Center to, I believe, the base to the collector is 0.5 and base to emitter should be open. I could have that backwards, but you'll see here that in circuit 0.5 and 0.5. That's a good reading on an HOT. Okay, so we're good there. Next is going to be our C38, which is this guy right here. This is our C38 width cap, the horizontal width cap. You want to make sure that it's not shorted. So in this instance, it's going to be these two pads right here, and we will make sure that it is not shorted. It is not shorted. If we go to ohms, we'll go to here, and it should read, usually it's around 11 meg or so, but it counts down as it dissipates when you first start off. So anyway, sometimes it's 15 meg, sometimes it's 11 meg. That's where it starts out, but it'll dissipate as you get the leads on there because the leads in the meter are making it dissipate. But you just want to make sure it's not shorted, and it is indeed not shorted. So our C38 is good. Now our C36 is, sometimes there's different versions. You can see in here there's two caps here. There's actually C69, which is the blue one, and C36. Do I have that right? Let's look in here. I can't tell. One of them is C69, one of them is C36. Now, there's some versions of the K7000 that have a single cap, one big green cap with 4 legs. That's C36. On this particular version, there's a C36 and a C69. So you're just checking to make sure that these aren't shorted either. And the way you test this is you're going to read a diode across it, just like your HOT. And that's because it's part of the HOT circuit. So I'll just show you here. So these two caps in here, there's the blue one and the red one. Those will correspond to these 4 pads here. 1, 2, 3, 4. 1, 2, 3, 4. So you're going to want to read across them diagonally. You want to make sure you're reading like a diode. So we'll go to negative on this one, positive here. Now let's go back to there. Do I have it backwards? There we go. There we go. Sorry, I had my negative on the wrong side. So negative on this side, positive over here. You read a diode and a diode. And of course your other pads sound the same trace, so it's still going to read the same thing. But you want to read your diode. You're actually reading through diodes in the circuit. So that's a good reading. That is a reading you want to have when you're reading across the C69 and the C36. If you're checking to make sure you're not shorted. 1.5 meg and 4K. So anyway, you're just checking to make sure it's not shorted. So our C36 is good. Our C69 is good. R97, R101, R104, R89. Our diodes in the rectifier circuit, R103. So now I guess our HOT is good. So the next step is the voltage regulator. And that's really the kind of the last thing. I mean, sometimes I'll check these diodes in here. It's D13 and D14. There's a couple of diodes in here next to the flyback. It's kind of hard to see, but one of them is right here. It's hard to see, but there's D13 and D14 are in here. Usually those really don't go bad. And if they do, they don't affect the power. They really affect your vertical collapse type of thing. But we can check them anyway, just so you know where they are and how to check them. But there's 2 different kinds of voltage regulator. I have videos on this already. For this particular type here, the STR3130, you're going to want to check pins 3 and 4. And you can check that 2 ways. You can actually go directly to pins 3 and 4 of the voltage regulator, or you can just go to the B plus resistor, because these 2 wires go directly to pins 3 and 4. On the other style, it's fatter. I believe it's the STR30123. I forget what it is. But it's the fatter one that uses these 2 holes and not that hole. You want to go to pins 1 and 4. But anyway, on this particular type, it's these 2 wires go to pins 2 and 3. So you'll see here it should read around 180 ohms. So if we go to our ohms selection and we go to our B plus resistor and we test it, 180 ohms, 182. So that means our voltage regulator is good, because if our voltage regulator was shorted, that would read 0 ohms. So just for the sake of completion here, we'll go ahead and go back to our diode checker, since it's a transistor inside of there. We'll go to pins 3 and 4, and there's our diode. Now it doesn't read 0.5 because we're reading, like, again, we're reading through this resistor. If you were to take off either one of these two wires and then touch this, you'd read your 0.5xx. But because we're reading through the resistor, it's 0.154. So if we go back to our ohm setting, you'll see it's 180 again. 180. So yeah, so that's good. That's about it. I guess we can do our D13 and D14. So if you look in here, D14 is here, negative is on the right. Okay, let's go the other way. I had them backwards, it looks like. Yeah, I had trying to look in there without being able to see clearly, I had it backwards. So anyway, so there's D14, and you can see that we're reading good. And D13 should be right in front of it. Oh, you know what? That was D13. That's why I had it backwards, because this is D13. And D14 is the other way around, right next to it. And that's a normal reading, even though it's not 0.5 or 4 or 6, but it's still a good diode. It's not shorted or open. So that's about it, guys. I kind of wish I could have found something that was obviously bad, but it turns out that everything in the power circuit appears to be good. Nothing should be keeping it from powering on based off what I just did the testing for. So I guess what we can do is give it a good cursory look on the bottom, make sure there's no lifted pads. We'll fix this pad over here for the filter cap later. It's not, the trace hasn't broken, so we'll fix it later. This needs to be reflowed because of the heat from this area, but we'll take care of that later. Just looking around here, because the cap kit and the flyback has been already previously installed, and it looks like they did a fairly decent job of it. I don't see anything offhand that looks bad. Yeah, it seems like it's okay. So I guess what we can do is get a tube out. Oh, wait a minute. Huh. The bipolar caps are missing. There's one here, one there, and one there. There's 3 caps here. They're all bipolar, and you can see they're all missing. If we look here, you can see all the way through the board, maybe. Let's see, there's one there, there's one there, there's one there. They're missing. So we'll have to put those in there. So let me dig through my stash and see if I can find some of those. And I'll get those installed. But everything else looks okay. So let me get those bipolar caps installed. I'm glad I looked it over. I glossed over that completely looking at it before. That's why it's important to take your time and look at this stuff. So let me get these installed. I'll get a picture tube, and we'll get it on the tube and we'll fire it up and see what happens. I'm not sure why this is sitting so high here. What the heck? There's a capacitor installed here that shouldn't be. You see this here? That's not supposed to be there. This capacitor is not supposed to be there. It's soldered to the leg of that resistor, and the other side is going down through this jumper. Someone has cut this jumper. There's a jumper right here. Somebody has cut this jumper, and they've put this capacitor in here. I have no idea what that's for. Someone did it on purpose, so I'm not going to remove it unless we have issues. But this is quite an oddity. Why someone would leave these caps out, whatever this is all about here, whatever all these bodge wires are about, whatever this red wire is about, this is an odd one for sure. So I guess I'll leave that alone. But let's get these caps in. I'll get the thing on the tube and we'll fire it up. And fingers crossed it works without having to make any modifications. Oh, and I got to get the remote board. Is missing. So let's get that work done, and I'll come back and we'll see what happens here. One moment. Alright, so I got the 3 bipolar caps installed. I did not have the normal ones that go in here, the smaller version, but these are all the correct kind. They're bipolar, 50 volt, 10 microfarads. So they're all the right rating and kind, but they're a bit bigger than they normally should be. But they're the only ones I had on hand without having to dig into an entire cap kit and steal them from the cap kit, which I have a couple of those on hand. So I got that done. I got a lot of the reflow work done. I reflowed some of the areas here that needed it. What else? I realized we forgot to test D18, so I'll have to test that, which is why I have the meter leads in my hand here. But I got the reflow done here. I got some reflow work done here. And I got the bipolar caps installed. So let's test D18. Again, D18 is a diode across the horizontal coil. And it's kind of hiding down in here. Let's see if I can show it to you. It's hiding, kind of see it right down in here. And the stripe is on the right and the positive will be on the left. So negative on the right, positive on the left. So if we go down in here and we test this diode, which I guess we could probably test it on the back side. So we're going to want our negative here. Is that our diode? Our diode is here. Negative here and positive here. D18's good. Okay, that was the last thing to test. So we've tested everything that would keep this from powering on, and everything tests good. So we don't have to worry about any kind of power issues, so to speak. It looks like somebody has... it's hard to see. Looks like somebody has snipped out the old D18 and put a different one in here and soldered it to the original legs. So someone was doing some troubleshooting. There's D18 in there. There you can see. It looks like somebody has snipped out the old one and soldered a new one in place to the original legs. That's quite interesting. But we know it's not in backwards, because if that was in backwards, it would take out most likely a C38, which would take out the fuse, and everything tested good. So that's not the issue. So let's. I also forgot to talk about the neck board. Neck board looks okay. The C204 has been replaced, so that's good. I don't see anything obviously wrong with it. The neck board transistors are secure. The resistors here aren't touching each other. I like to spread these out so they don't generate, because they generate heat, and they don't want to. You don't want the heat inducing onto the other ones to make them even hotter. So you spread those out. And I like to take all of the color pots and put them to center, so we have a good base to start with of what the colors look like. Okay. All right. So now let's get the tube, and we'll get this hooked up, and we'll cross our fingers. So. This nightmare out of the way. Alright, one moment, be right back. So we got the tube all set up, ready to go. This is a dedicated K7000 tube. It's always best to use the original compatible tube. That way, you know, if you have geometry issues or size or vertical problems, you know it's not a problem with an incompatibility of a tube issue. And instead it's down to, for sure, a chassis problem. So, with that being said, we always want to count to 5, at least to 5. So we'll get our yoke hooked up, which of course, again, goes right there on those pins right in there. And we'll want vertical is the narrow set of pins, and horizontal is the wider set of pins. Make sure you push it down all the way. Use your hand to support the backside when you push down so you don't crack or break the solder joints. And we'll get our horizontal hooked up. Now if you ever hook this up and you got an image that's flipped, like it's upside down or mirrored, all you have to do is just take these connections and flip it, and that'll flip the image up, down, left, or right. Oop. So we have our yoke installed. We'll hook up our degauss coil, which you don't have to, but I do anyway. We'll hook up our anode. Which this way. Alright. Make sure you get both. I hold this back and make sure you put one hook in and then the other hook in. So you want to visually make sure both hooks go in. Yep. And then flip the cup over it. We'll hook up our neck board. And if you're leaving this hooked up to the tube you're testing it on, you want to make sure none of these wires are touching the tube neck itself, because this gets very hot and you don't want these wires to be touching it and melt the wires. So make sure that's all away. You usually take a zip tie or something and tie these out of the way when you're done. But for this purpose, since this is not staying with this tube, I'm not going to worry about that. But it looks like everything's clear. So now we'll hook up our ground. It looks like someone cut it. I don't have my wire strippers here, so let's just do it the old-fashioned way. Alright. So we'll hook up our ground here, or dag wire if you will. And I'll just throw a wire nut on real quick just so we don't touch anything we're not supposed to, so that's good. And this has a frame ground. This ground connection here is coming off the frame of the tube, which you don't have to hook up because it's all connected through the dag wire. And it looks like it's already got a frame ground going to the chassis, so that's already hooked up. So we'll leave this off. The original one I had on here did not have that, so this was added on afterward to get rid of video interference and stuff. But okay, so I mentioned counting to 5. Oh, I almost forgot. I have the remote board from the chassis that was on this tube previously that I'm using for testing. So we're going to go ahead and hook that up. Okay. So I mentioned counting to 5, and I've said it before. Always count to 5 before you power these up. We got anode is number 1. Neck is number 2, yoke connection is number 3, which you hooked that up first. We got our chassis ground or dag ground for the tube is number 4, and video is number 5, video connection, which we don't have yet, but we will. If you want to get technical, you want to count to 6, I guess, because if you have a remote board, you want to make sure that's plugged in and hooked up. If you have the pots directly on the chassis, of course you don't got to worry about that if it's a 19-inch or something, but always at least count to 5. You want to be doubly sure, count to 6. Anode, neck, yoke, ground, video, and remote board. So there you have it. So let me cut away here, and we'll flip this around, and we'll get the camera set up, and we'll fire it up for the first time and see what happens. Alright, ready to go. We have our video hooked up, we have our power connected, we got our remote board ready to go, or at the ready. And I don't have it secured, which isn't very safe, but it is in the frame and on the holder, so we're all secure there, safe and sound. I just don't have the screws in, but it'll be okay. Alright, so let me get the camera on the tripod and back us up here. Alright. Me in my short shorts. I'm not embarrassed. I don't care. Okay. Fingers crossed. Does it fire up? Let's find out. 1, 2, 3. It does indeed turn on. No smoke yet. Do we have an image? Oh, we're not going to have an image. I don't have my board plugged in. Now my board's plugged in. Let's try again. Take 2. Nothing yet. Okay, so that being said, we'll turn this off. And the way that I adjust this is, I should have done this beforehand. I didn't realize it until just now. But basically, the way I adjust this is we'll turn our contrast and brightness all the way down. Completely all the way down on brightness and contrast. Then we'll turn it back on, and we turn the flyback up until we get the raster lines. Then you turn the flyback back down until they just go away. and then turn your brightness and contrast back up accordingly. Now, as the monitor heats up and warms up, the raster lines may come back, but if your flyback is good, they shouldn't. But if they do come back, you can turn them back down a little bit. But for testing here, I got my brightness and contrast turned all the way down. Let's turn it back on. First of all, let's see if the flyback is even turned up at all. It is not. The flyback is 100% all the way down. I think this may be a case of not knowing what to do, because these flybacks, the brand new flybacks, always ship with the flyback knob or the screen pot completely turned off all the way down. And the person that had this may not have realized that, because I just tested it and it was all the way down. So that may have been the entire issue with this initially. Obviously also the missing bipolar caps, which I don't know what would have happened if you powered up without those. I've never done that. So let's turn the flyback up just a little bit, right, probably about right there. And then we'll turn this on again. And let's see if we can get an image here. Hey, all right. Okay, so again, here's the deal. Flyback is turned up until you get the raster lines. Well, it's out of focus. There we go. So here's our raster lines, as you can see. Now we turn it back down until the raster lines just go away, which is roughly there. Nope, still there. I can still see them. Right about there. So there, now our screen's black again, as you can see. So that's where you want to have your flyback set to. Now, we'll turn up our contrast and our brightness. Our image is too wide, it's too red, but that's fine. Am I missing a color here? Let's go into our test mode. I am missing, looks like I only have green. Yeah, monitor, I have no red and no blue. Oh, my video connector is no good. Okay, so now I have green and red, but now I have no, I'm still missing blue. There's green and there's red. Yeah, like I said before, amateur hour here, so let me get my connector fixed and we'll come right back. So this connector that goes to my test bench here, that goes up to I have an NBA Jam board plugged in, which you saw. It's just too far gone. All the years of back and forth and plugging and unplugging back and forth. The wires are broken off. I tried to shove them in there just for testing, but it's just no good. So I'm just going to use my test pattern generator. I have zip ties on here to keep that from happening on these, and it goes right to here. So let's get this turned on. I actually have this on already. So let's get this fired up and see what happens with the test pattern generator. Okay, all right. So hopefully this works. Let's see. We're on. Here we go. Okay. Oh, uh-oh. We're still missing blue. Well, that's not good. Brightness, contrast. No blue. So it's not the header pins, because those were good. I can reflow them, but they were in good condition. If we go through here, I have no red either. What's going on here? I had red. Something is very wrong here. Just, damned if I know what it is. Oh, holy crap. My red, blue is on, but my red is not. Somehow it got turned off. Hey, look at it. There we go. But my blue is definitely on. There's green. And I didn't have any blue with the other setup either, so there's something going on with the blue. Well, it works. Oh, crap. Each position. It's way too wide, but we'll call it right there. Vertical size. You can see, here's a good example of the 50-60 Hertz pot. If you look up at the top, you can see how it's folding over on itself up here. As I increase or decrease the size, it folds over on itself, and that's just a simple adjustment on the 50-60 Hertz pot, which I'll show you later. But Well, let's turn this off and see if we can figure out what's going on with the blue. Alright, we're back on the bench. Let's see if we can get this figured out. So the video header pins, they look okay. They've already been reflowed, it looks like, too. These guys over here. Blue is the third pin, 1, 2, 3. And it goes to here, which, yeah. We can test, it's most likely a neckboard problem, but we can test the, I don't know if they're NPN or PNP. We can test these transistors here, which shouldn't be too difficult. Let's see. Okay, so this should be for the red. Okay, that one's good. We'll do green. And that one's good. Now let's do blue. That's good. Like I thought, probably a neckboard problem. So let's cut this loose here. If it's bad, I do have transistors to replace it with. I mean, if the blue transistor is bad. The pots aren't broken. Let's see, here's blue. The, do I have, where's it at? Okay. Let's see. If the blue pots are broken, if one of them is broken, I think it's the drive. If the drive is broken, you won't have any color at all. So let's just exercise them. Well, that one's awful stiff. But we'll set it back in the middle. Just giving them a quick inspection. They're not broken. Solder joints, they don't have any cracks on them, but let's go ahead and reflow just for the sake of reflow. But I'm betting we have a bad transistor. And we'll grab these other ones here while we're doing this. Alright, turn my fan on here. I'll looking this over. That's loose. Shouldn't affect the blue, but that's our G2 header pin is loose as a goose. Alright, take care of that. Do I dare dream? I think I found the problem, ladies and gentlemen. You see what I see? A trace, broken from the trace. All right, or a pad, broken from the trace. I think we found it, gents. All right, there's a better shot. Babuya Bakai. And that just, if we follow the traces, if we follow this one that's broken, follow it this way, guess what it goes to? Right to our blue drive pot. Okay, I bought these stupid, I had a really nice fiberglass pin that I would use to scrape away these masks, but I ran out. I tried to go on Amazon to find the same one, but I couldn't find it. And these are more like a paintbrush bristle type of crap. These don't do shit. These don't scrape off anything. I mean, it's like paint bristle. They're not they're advertised as fiberglass scratch pins, but they are clearly not. I can scrape it away to my heart's content. There's no bristles falling off. There's no fiberglass remnants. This is not a fiberglass pen, even though it's advertised as a fiberglass scratch pin, quote unquote. So these are junk. I mean, I can try until the cows come home, and this will not take off that trace. That's nothing. So those are garbage. So I have to, until I can find a good source for another fiberglass pen, if anybody out there knows, let me know. I'm just going to do the old-fashioned method of scraping away with the razor knife here. And this is the method that I've always used. It's just easier than running bodge wires. We'll just expose the trace and put a solder bridge, and we'll call it good. You'll leave your iron on there to heat up the pad and the trace to allow it to flow. I'm not happy with that. Nope, not one bit. Well, that's better, but there we go. It's not pretty. Oh, I had you. Oh, you bastard. Oh, I guess it'd help if you could see what I'm freaking doing. Sorry about that. Okay. So you can see there I've got that jumpered over and it's secure, but I don't trust it. It'll work for what it is. I mean, that's nothing to write home about, but it'll work. And let's reflow the rest of these. This is, believe it or not, a very common issue. If you don't have heat sinks attached to these neck transistors, they can get knocked around in shipping or just over the life of the chassis. And a very common issue. There were a couple lifted pads on the main board as well, so this one was actually broken. I don't know if somebody did it previously, but that's solid. That's solid now. It's not moving or budging at all. And you can see the little solder bridge I made on there. And you can run a bodge wire. That's just perfect. That's perfectly fine. It might be even more secure, but this works just as well. And after reflowing those and getting this nice and secure on there, I can wiggle this all day long, and it's good on there. So, but I don't think I can trust it over time. And I also don't think I have a bodge wire except this magnet wire, which is too small for this. I mean, I could use, I'll toss some magnet wire on there. I don't have any other wire here. Let me do this here. I'll toss this on here just to make it work for now. What happened to my, there. You gotta scrape the coating off the outside of this magnet wire, which I guess I realize now you can't even see. Gosh dang it, sorry about that. There you go. I was just scraping off the edge of this magnet wire. so we can solder to it. And you can see it's just a pinball coil. I use magnet wire for that. So let's solder this on here. That goes right to here. Let's get a little bit more solder on there. There we go. That's about perfect, as you can see. Oop, or not. There you go. Soldered right to it. And this has a coating on it, so you don't got to worry about it being conductive on anything. So we'll just try and conform it to the trace. And we'll come around here and cut this off right about there. And then we will kind of scrape. Oh, gosh dang it. Well, it's going to end up being shorter. I cut it accidentally with the cutters trying to scrape it away. That's all right. We'll just do it the old-fashioned way here. We'll just right, and get some solder on here, and let's just solder this to that. All right, that's better. There we go. Okay, I'm happier with that. Alright, so there you go. There's that wire. And now we're good. So, sorry about the, again, the amateur hour type of stuff. But yeah, there you go. It's running along the trace. And it shouldn't be conductive. And we should be good to go. So, let's get our cover back on. Not 100% necessary, but in the efforts of professionalism, we'll go ahead and do this here. There we go. Where did my other one go? I just had it. Here it is. I'm blind. Don't get old. Well, any bets now? Let's find out. Okay, we'll get it hooked back up to the tube. Fingers crossed. We'll see what happens. All right, hole hooked back up. We got our 5 count or 6 count taken care of. Anode, neck, yoke, ground, video, and remote board. And we have our test pattern generator ready to go. Let's turn it on. And do we have blue? Let's find out. Let me get the, oh, sorry, tripped over my chair there. Okay, here we go. Oh, forgot my power. I guess you count to 7. That's not embarrassing, but I don't edit out mistakes. So here we go. Okay, we got power. Do we have blue? We have blue. Hallelujah. There you have it. Let's see. So our contrast is too high. And our brightness, we need to put our brightness about, let me show you where to put your brightness here. Okay, so you can see that the background is not quite dark or completely black. This area here is black because it's outside the raster, You can see how this is not black. Your black level, at the optimum setting, you want to match that black. So you want it to be about right there. That's the maximum setting that your brightness should be. So if your screen is still too dark for that, then you have a weaker tube, and to compensate you'll have to turn up your contrast or your flyback, but you're going to get, we already know that if I turn the flyback up any more than this, I'll get the raster lines. So, but you may have to turn it up to find a happy medium, but this is where you want to have your black level set. So that being said, let's put this back on the tripod. And we'll see if I can get this looking better. That's pretty good. Sharpness. Can't get much better than that. Vertical size. Let's go to our bars here. There we go. So now you can see we've got the fold over up top up here. And the more I increase the vertical size, the more the fold over gets. So I'm going to show you how to adjust that out. There is a pot on the back of this chassis called the 50-60 Hertz pot. And it's this little guy right here. If it'll focus, will it focus? It's that little guy right there. So you simply adjust that, and that will get rid of this fold over and adjust it down to the bottom to where you'll see. I'll adjust it on screen here and you'll see what happens. Alright, so you can see that there. Let me get my screwdriver back out. Alright. And before your very eyes, so there's the fold over. I adjust the pot, and right about there is about as good as you're going to get, because I need to adjust the vertical position and vertical size. Yeah, that's probably about as good as you're going to get. But it's no longer folded over. Red looks pretty weak on this tube. You can see the red is kind of weak compared to green and blue. It may need rejuvenation on this tube. That's a whole separate video. But yeah, I mean, I'm not too concerned about this. Let's see if we can hook up. Let me get my JAMA connector fixed for the video, and let me hook up an actual PCB. I like using the test pattern generator, but it doesn't give me a realistic portrayal of what an actual game would look like. And it's hard to adjust the colors. I mean, you got the color bars on the test pattern generator here. Right, you can adjust your colors here, but to me, I know what the image should look like on NBA Jam. I know what it should look like off memory, how purple it should be, how blue it should be, how red it should be. So I just go off of memory from that. Like I say, I'm not a professional. If I was a professional, I would know how to do it based off the color bars here. But let me get my actual JAMA video connector fixed, and we'll test it that way. Hold on a minute. So I got the CGA connector from my JAMA harness wired in. I just stripped the wires and shoved them down in the contacts just temporarily, so I'll fix it later, but at least this will get me working for now. So let's get this back on the tripod. Let's see how this looks, because I think this will be a much better and more accurate test of how it's going to end up looking. Alright, so here we go. And again, it doesn't really matter because this chassis doesn't stay on this tube, but it should be okay. Well, it's way too wide. For one, it looks pretty good, but it's way too wide. Contrast is a bit too high. That's better. Let's just skip this. And it's too bright. That's pretty good, but the colors are wrong and it's too wide. So let's turn up red just a bit, because it should be a bit more purple there. That's pretty good. Green. Blue is all right. Right about there is good. I'd say that's pretty good. That right there is about right where it should be. it looks the background is a bit more purple in color in person. In person, it looks perfect. The background is purple, just like it should be, but in the camera, it looks more blue, so you have to forgive that. But I think that's pretty good for size, vertical position. I think that's the limit of the vertical position on the height. It could be part of that mod that someone did. I can't say. Well, the contrast is too high. There we go. Right there. Perfect. Perfection. Brightness maybe. That's good. Okay, yeah. Check it out. There you go. But for the width, actually, if we look here, H position, we got more space here than over here. So let's go right about there. And let's adjust our H size. I'm sure everybody knows, but the H size is going to be this guy right here. That coil right there. Never reach in here with it powered on. I'm an idiot. Never do what I'm doing. Don't reach in here when it's powered on, because you might hurt yourself if you don't know what you're doing. I mean, I somewhat know what I'm doing, but I'm still an idiot. But you can still point anyway and stuff. So anyway, that's our H coil, width coil. You can adjust it with a plastic tool like this. You never want to use a metal Allen key because you'll damage the ferrite core. So you slip this in there and you can adjust your size with one of these guys. So let's do that. That's a pretty good image. That's about right where it needs to be. It looks much better in person. It needs a bit degoused. If we go to our test menu here, we can probably see. Yeah, see, it needs degoused up here, so it looks kind of odd on camera and in person, I guess. But yeah, it's just basically the red. Anyway, so let's get out of here, and we'll adjust our. Yeah, in person, this is perfect. If it wasn't for the discoloration from the degauss, I don't know if I can get rid of it. I don't know, but this is perfect purple. Perfect. This is fantastically adjusted right now. It just looks more blue in the camera, so I have to take my word for it. But let's adjust our H size here. Oh, damn it. I dropped the adjustment tool, and I'm not foolish enough to reach in here while it is powered on. So let's get our adjustment tool in place. Now let's turn it back on here. All right. Yeah, that looks pretty good. So let's spin this around here. And you can see the picture shrinking in as I do this. And that's pretty good right there. You can see a little bit of the border all around. There you have it, guys. This video is super long, but I wanted to make a good first video on the new channel here. And I was kind of disappointed nothing was actually wrong with this. I always prefer to have something wrong with the chassis so I can fix it, but trust me, I've got a whole nother, I got 5 more right there, and trust me, some of them have pretty good bad issues. Anyway, so there you have it, guys. First chassis on the channel, fixed, ready to go. I'll adjust it and it looks perfect. And I appreciate you watching. Stay tuned for a lot more content. Thank you very much.